Come back. In this class, we are going to discuss about how to design any logic using NMOS and using PMOS. Okay. Now, first of all, we will see the NMOS design logic. Later, we will talk about PMOS design logic. Now, you can observe different circuits based on NMOS logic and PMOS logic. Just quickly recall the shortcut to design any circuit using CMOS, NMOS and PMOS. PAP is the shortcut I already said to you, where the first P stands for PMOS and the second A stands for AND or NAND, and the later the P stands for parallel. That means PMOS should be connected in AND or NAND configuration in parallel. Is it clear? Okay, now you can talk about NMOS. Yeah, absolutely. Okay, NMOS in and NAND configuration, it should be connected in series. Okay, if you talk about NOR, you can observe very clearly in NOR or OR operation. Okay, the PMOS should be connected in what? Series, and whereas the NMOS should be connected in what? Parallel. Based on this shortcut itself, I am going to design any logic using NMOS, PMOS and CMOS. We already seen the logic CMOS. Now we are going to see NMOS. Is it clear? Now you can observe very clearly. Now let us consider two input NAND gate here. Okay, two input NAND gate. First of all, I would like to design a basic inverter. Okay, now you can observe that we know very well in NMOS inverter, the pull-up transistor is a depletion mode NMOS and the pull-down transistor is an enhancement mode NMOS. Now for this transistor, you have to apply input. Then it may be VSS and it may be VDD, and it is what? Absolutely output. Is it clear? Now based on this, I am going to design here. You can observe very carefully here. The question is what? To design a two input NAND gate. Now you can observe that the pull-up transistor, I am not changing the configuration of the pull-up transistor. This is as it isly connected, but here in the pull-down transistor we require how many inputs? If you observe two input, and which configuration it is? NAND configuration. We know very well in NAND configuration the NMOS should be connected in absolutely series. Therefore you have to connect in this fashion. I hope that are you clear. It may be VSS, it may be what? VDD, and this is the first input. Okay, sorry for that. Okay, this is the first input, let us consider A, and this may be the second input, let us consider B, and it is your Y. Okay, now tell me, we have to connect any inverter here? Any inverter we have to connect here? Yeah, absolutely not necessary. Why? Because in the Boolean expression of NAND we are having already the complement. Is it understood? Okay, similarly you can observe that two input NOR gate, you can observe two input NOR gate. Okay, now the pull-up transistor, I am not changing any pull-up transistor. What is a pull-up transistor? It is a depletion mode transistor. Okay, and here the two transistors should be in parallel because it is a NOR operation. I hope that are you clear, all of you? Okay, like this is A and this is B. Is it understood? And this should be connected to VSS and it should be connected to VDD, and it may be what? Y. Here also, since the NOR consists of a complement in its Boolean expression, need not any inverter. Is it clear? Now you can observe an important thing. Let us consider three input AND gate they said to design. Absolutely, three input AND gate. You can observe very clearly. I am using some other color. You can observe I am not changing any pull-up transistor. You can observe the pull-up transistor is a depletion mode transistor itself. Okay, and here how many inputs are there? Three inputs. Therefore, three NMOS transistor should be connected in series, and it may be VSS and it may be VDD. Now you can observe this may be A, this may be B, and this may be C. You have to collect output here A, B, C, but don't forget here in this we do not have any absolutely complement in the Boolean expression. Therefore we have to use an inverter here. This is our inverter. Okay, don't forget which inverter you have to use. Yeah, absolutely, NMOS inverter you have to use. Okay, this is your inverter. This is VSS, this is VDD, and this is an input. The output should be connected to input. Then you can call this one as three input AND gate. Is it clear, all of you? Now we will see some other Boolean expression based on this. Let us consider Y is equals to AB plus C whole complement. Okay, now three inputs are there. First of all, we will talk about the pull-up. I am not changing any pull-up. Is it clear? This is my pull-up. Okay, now you can observe in these three inputs, the first two are AND operation, and this is with C an OR operation. Therefore, first we will talk about AND operation. We know that in AND operation, the NMOS should be connected in series. Therefore, I have taken like this. This is what A and this is what B, and this AND is in parallel with this C. Why? Because it is an OR operation. Then you can observe this one like this. Is it clear? C. Okay, now it is what VSS, it is what VDD, and the output is taken here. Now will you please tell me any inverter is required here? Any inverter is required? Not required. Why? Because it is already, complement is given in the Boolean expression. Is it understood? That's it. In this manner you have to design any Boolean expression. I will go with some other Boolean expression. Let us consider AB plus CD. Okay, you can observe that. Okay, and I'm not changing the pull-up transistor here. I'm going to use the same pull-up transistor. You can observe that here there is an AND, therefore I required two transistors in series here. This is A and this is B, and here two transistors in series. Okay, C and D. Is it clear? This is C and this is D, and these two should be in parallel. Therefore it is connected like this, and it will be what VSS and it will be what VDD. Then it is what, not, it is not a Y. Why? Because there is no complement in the Boolean expression. Therefore you have to use what? Absolutely an inverter. Is it clear? Now it may be VSS, okay, and it may be, sorry for that, okay, I can write in here VSS, and here it is VDD. There is no space for me to write, sorry for that. Okay, VDD. Now you can observe that it is VDD. Okay, now this is a depletion mode transistor and it is tied together, and this output is given as input, and now it is Y. I hope that are you clear, all of you. Now can anybody try to tell what should we have to do in the PMOS transistor? What should we have to do in the PMOS transistor? Now you will observe the inverter of PMOS transistor. You know very well that in the PMOS transistor the input is given to pull up, and the pull down is what? Absolutely, it is in depletion mode transistor. Therefore you should not change it. Is it clear? Only the input is applied to what? A pull up transistor. Now the output is taken here. Is it clear? Based on this you can able to change this configuration. Okay, if they said 2 input NAND gate, you should not change the pull down transistor. Just the logic should be applied here. You can observe that if it is a 2 input NAND gate and A and B is taken here like this, and there is a bubble here, and you should not change any pull down transistor. It should be connected as it is. Is it clear, all of you? And the output is taken here. Is it understood? In this manner you have to design any logic using NMOS, PMOS and CMOS. That's why what is the shortcut I said to remember? PAM. Is it understood? Thank you very much for each and everyone. Have a nice day. If you are having any queries, you may please comment.